This is section 3.2, solving linear equations in the form ax plus b equal to c. So we can apply the information from this section to the next section as well. The problems are very similar. So let's take a look at the first example, which is basically an equation that contains fractions. So if we have an equation with fractions, we can eliminate the fractions by multiplying every single part of the equation on both sides by the least common multiple, the LCM. Between 2, 4, 3, and 6, the LCM would be 12. So what we want to do is, again, multiply every single part of the equation by 12, and then we can get rid of the fractions. So let me show you. I'm going to recopy this equation, and then we're going to multiply both sides of the equation by 12. Okay, so we multiply every single part by 12, and when you multiply by 12, you are multiplying in the numerator for every single part here. So you can write 12, or we can even write 12 over 1. So you can think of this two ways. We can multiply through 12 times 1, we get 12 over 2, which reduces to 6, or you can just reduce the 2 and the 12, which gives us 6 times 1, which gives us 6x. So the first part simplifies to 6x. Plus, same idea for the second part. 4 divides into 12 3 times. 3 times 3 gives us 9x. Minus 3 divides 12 4 times. 4 times 5 is 20. And then 6 divides 12 2 times. 2 times 5 gives us 10. The resulting equation contains no fractions. Once we get to this point, we combine our like terms first. And when we combine, that's going to give us 15x minus 20 equal to 10. Next, add 20. 15x is equal to 30. Divide both sides by 15. X is equal to 2. You can easily check your answer by taking 2 and substituting it back into the original equation for x, and checking to make sure that the right and left sides are equal. Example 2 contains decimals. And so in order to solve, we can either keep the decimals or we can eliminate them. And one way to eliminate the decimals is to multiply, in this case, every single part of the equation on both sides by 10. The reason being 10 is because we need to move the decimal for all of these numbers just one place to the right. So to move your decimal one place to the right is equivalent to multiplying through by 10. So then we can rewrite our equation. And we multiply every single number, or every single part, by 10, which will move the decimal one place over to the right. Okay, so multiply by 10, which now we have 47 minus 5x minus 3x equal to a negative 1. Combine like terms. 47 minus 8x equals to negative 1. We subtract minus 47, both sides. Negative 8x equal to negative 48. Divide negative 8 on both sides. And we simplify and we get x is equal to positive 6. And again, you can take your answer, plug it back into the original equation for x, and then make sure that the right and left sides are equal.